All right. Welcome back. We are now going to take a look at frequency tables. A frequency table is just that. It's a table of frequencies, either individual values, or it could be a range of values if our numbers are too spread out or we have too many numbers. And we call those range of values classes. I have one example here to help illustrate the point. It's the amount of money in an Irondale staff member's wallet. So I took a random sample of 40 individuals, and these are the dollar amounts that they said they had in their wallet currently. It would take a very long time for me to list out by every single number, have it organized. So I'm going to create classes, so equal sized groupings of the numbers. Our smallest number is 25, our biggest is 75. So I'm going to really conveniently just go like this, go 20 to 29, then 30 to 39, 40 to 49, 50 to 59, 60 to 69, and then 70 to 79. And from there, the next column, this one's kind of optional, but it's creating a tally. So if your numbers weren't already ordered from least to greatest, you'd probably have to do a tally in order to count the frequency, how often a value occurs in that class. So I'll show that here. We've got 25, which fits in there. We've got 31, 32, 32, 36, 36, 37, 38, 39. Then we have 41, 42, 42, 42, 43, 46, 47, 49, 49, 50, 55, 56, 56, 57, 58, 61, 63, 65, 65, 66, 66, 67, 70, 72, 72, 74, 74, 74, 75, 75, 75. And then we just count that up for the frequency. 1, 5, 8, 9, 6, 7, and 9. And if I add all those frequencies up, that will equal 40. 9, 18, 24, 31, 40. So this is just a frequency table, counts the frequencies. But we can take that one step further. We can create something called a histogram. It's a bar graph. It's a bar graph of data from a frequency table. The x-axis is going to represent the classes, and the y-axis is the frequency. Because we as human beings are a visual species, so we like to see things, which means I'm going to show it as a bar graph. So our y-axis is the frequency, and I'm just going to go by ones on that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And along the x-axis, it's the classes, so it is the money in wallet. And there's a few different ways that you can label along the x-axis. I'm going to do the full class. Other ways you may see it where it is just the largest number, or you may see it where it is the middle number of it. But for the purposes of us right now, I am just going to go like this. So you start to get a feel for what this graph looks like. I'm going to change colors in order for me to do my bars. So from 20 to 29, there's a frequency of 1. All right. From 30 to 39, there's a frequency of 8. From 40 to 49, there's a frequency of 9. 50 to 59, a frequency of 6. 60 to 69, a frequency of 7. And 70 to 79 with a frequency of 9. So this frequency table is really good for getting a quick kind of summary or glimpse of where individuals may fall within this data set, within this information. But it doesn't tell you any information about any particular value. So that's one of the downsides of using a histogram where you have classes instead of specific values. If we did it by individual values, then on that bar or this x-axis, we would have probably 35 numbers, because how likely is it that many people have the exact same dollar amount? So it would take a lot longer to create a bar graph, a histogram that gives us relevant information. So that's the trade-off if you're doing classes, is it's faster to create the graph and it's faster to interpret some basic information. However, you don't know anything about, say, the values that are in this class. If just by looking at this, you know that there are 6 values that fit in here. They could all be 50, they could all be 59, or they could be spread out some way. We don't exactly know. However, this is a really good way to better represent our data. Now, if we were talking about histograms in general, looking at a picture of them, we can use some vocabulary terms to describe how they look. So this first one is symmetric, or we could call it bell-shaped. That's because it looks kind of like the Liberty Bell. This is roughly a normal distribution, which we'll get into a little bit later. So right now, if you were to identify that shape, you'd call it just bell curve or symmetric, because it looks like it's got a nice line of symmetry right there. But if we are pulling away from that symmetry, then we have something called skew. So I'll erase the bell-shaped part because we're going to run out of room a little bit. This graph here, it looks like it wanted to be a bell shape, but that this end was pulled and stretched out a little bit. So we would call that skewed left, because that was the direction that the tail was being pulled. So then likewise, this one here is skewed right, because we think of it like you are stretching, you're holding both sides of the graph, but then you're only stretching one of them out to give it this little tail. And that's okay if that happens. We're just describing what we see. Then the ones on the bottom here, this one where everything is pretty close to being similar, we call that uniform. It would be very strange if you had a large enough data set where it was completely flat, but if it's really close, then we would call that uniform. And then if you think back to measures of central tendency, we had this term called mode. And mode meant most frequent. Well, histograms are bar graphs about the frequency. So if we have 2 peaks here that it looks like we've got a bell curve going there, and then we kind of have a second one, it may not be quite as high, but a second bell like that, we would say that it's got 2 peaks, or we would call it bimodal. Yeah, sure, you could have trimodal or quadmodal or things like that, but if it's anything more than 2 peaks, and they don't need to be the exact same height, but if it looks like we've got 2 areas where it's pretty convincingly most frequent, then we would call that bimodal for our data. And those are just the basic ways that we can describe the shape of a histogram.